Nature of science. The nature of science. Over the course of human history, people have developed many interconnected and validated ideas about the physical, biological, psychological, and social worlds. The nature of science describes basic concepts about how scientists learn about the natural world. Number 1, the natural world is understandable. Number 2, science is based on evidence, both observational and experimental. Number 3, science is a blend of logic and imagination. Number 4, scientific ideas are durable, lasting, yet can change as new data are collected. Number 5, science is a complex social activity. And number 6, scientists try to remain objective and engage in peer review to help avoid bias. The natural world is understandable. Science says that the universe is understandable through careful study. Scientists believe that through the use of intellect, people can discover patterns in all of nature. For example, the same principles of motion and gravitation that explain the motion of falling objects on the surface of the Earth also explain the motion of the moon and the planets. Science is based on evidence. Scientific knowledge involves a combination of observations and inferences. Scientists use data to make inferences and formulate explanations. Data can be obtained through experimentation or observation. For example, scientists observe passively, earthquakes, bird migrations, and actively probe the world, as by boring into the Earth's crust or administering experimental medicines. Science is a blend of logic and imagination. Although all sorts of imagination and thought may be used in coming up with hypotheses and theories, sooner or later, scientific arguments must conform to the principles of logical reasoning. Scientific knowledge involves human imagination, creativity, and inference. Scientists must use their imagination along with data and their background knowledge. Scientific ideas are durable, yet subject to change as new data are collected. Science is a process for producing knowledge. Scientific ideas are continually tested by other scientists. The process depends both on making careful observations of phenomena and on inventing theories for making sense out of those observations. Change in knowledge is inevitable because new observations may challenge old theories. For example, in formulating the theory of relativity, Albert Einstein did not throw out old Newtonian laws of motion, but did show that they were not complete. Science is a complex social activity. Scientific knowledge is tied to social and cultural factors. Scientific work involves many individuals doing many different kinds of work and goes on to some degree in all nations of the world. Men and women of all ethnic and national backgrounds participate in science and its applications. Scientists must be able to communicate their ideas to their peers and to work with other scientists to compare ideas and data. For example, scientists talk to a lot of people about their ideas. They attend conferences, write articles, give presentations, and report the results of their investigations. Other scientists listen to new ideas from their peers and use them to help with their own experiments. Before the 20th century, and well into it, women and people of color were essentially excluded from most of science. The remarkable few who overcame those obstacles were even then likely to have their work depreciated by the science establishment. Also, scientific knowledge is also dependent on financial support, and this can influence, positively or negatively, which areas are investigated. Scientists try to identify and avoid bias. Since scientists that work in the same field may have the same viewpoints, they need to challenge themselves to avoid bias. One way to help get rid of bias in an area of study is to have many different investigators or groups of investigators working in it. Scientists use the same procedures and methods all over the world to make sure that science standards are universal.